Hello everyone. In this video, I'm trying to explain the primary differences between machine learning and deep learning and how these two different areas are different from artificial intelligence or AI as such. If you are observing this particular slide closely, we clearly can perceive that machine learning and deep learning are subsets within this particular broader discipline called artificial intelligence. So how exactly is AI different from machine learning and deep learning is what we'll try to understand first, and then move on to understanding the primary differences between machine learning and deep learning here. Let's say that you are given with a particular problem and you are asked to provide a solution to that. The solution could be a very simple solution, which generally is a rule-based approach, or it could also be a complex solution, which essentially means that you are creating a model by considering the given data. The model is essentially learning from the data, and we are trying to solve that particular problem by using this complex approach. Okay, the simple rule-based approach can simply be an explicit programming that you have implemented. So all what you're trying to attain here is to induce some intelligence to the existing systems. That's what AI model is all about. Right? It could be a simple explicit programming approach or a simple rule-driven approach, or it could also be a complex model that you must have created which leverages a given data. I believe you have pretty much understood what this AI is all about. Okay. And now let's dive into understanding more about the traditional machine learning model and a deep learning model. From what you're observing from this particular slide, you clearly know that there is a particular segment here called as feature extraction. So there is a manual process that's always involved here. A domain expertise tries to mine different features from the domain knowledge that he has. With whatever raw data that's given to him, he typically does the feature engineering and he extracts or creates multiple features that can be used as input to the model, right? So all of the features that are mined will be used as input to the model, and eventually you will be able to determine whether a particular observation is an object car or it's not a car in the given example. In the given example, whatever input that's presented here is generally a car or not a car. So this is a simple classification problem that you're trying to solve. So all what I'm trying to explain here is that there is a feature extraction phase that's involved in the whole life cycle. However, in deep learning models, feature extraction is not explicitly done. So there is auto feature extraction. So all of these different layers within your deep learning network generally extract the features by itself. So as we move deeper and deeper into the network, let's say that you are having multiple layers within your network. So you have this input layer. If you go to this particular slide, this explains a basic and simple deep learning model architecture. First, we'll have input layer, and then you'll have output layer. In between, you'll have multiple hidden layers. As you increase the number of hidden layers or dense layers in between, you are drawing more and more complex features out of it, right? The feature extraction here could be as simple as identifying the edges of a particular face in the initial layers, and in the later layers of your network, you might be trying to extract more complex features like eyes or nose of a particular human face. Okay. So this is the primary difference between a machine learning and deep learning model. The primary difference is the feature extraction process. Here, the feature extraction is completely manual in traditional machine learning. In deep learning, it's an automated process. Okay. And the second difference that I would want to explain here is the model performance. So the model performance of a machine learning model generally plateaus after a particular point in time. Let's say that on x-axis I am providing data volume. Okay. On y-axis I am trying to assess the model performance here. So as the data volume increases, the performance of the model also increases till a particular point, and then it plateaus thereafter. So we need not have like thousands or tens of thousands of data points for a traditional machine learning model to work well. We typically need good engineered features with limited amount of data also for a machine learning model to successfully classify a given car versus not a car in the given example, right? It's not necessary that we always consider classification. We also can consider regression problems as well. But all what I'm trying to explain here is as the data volume increases, the model performance only increases till a specific point of time, and thereafter it plateaus. In deep learning models, the model performance keep on increasing almost linearly, right? Almost linearly, and it keeps on increasing with the increase in data volume. If you are observing today's large language models, the large language models are exposed to petabytes of data. gigabytes and petabytes of data where you are having billions and millions of parameters to tune, right? Obviously, as data volume is increasing, the model performance also is increasing. And that's the primary reason why you are inputting large amounts of data thereafter, right? So this is another primary difference between deep learning and traditional machine learning models. So we need not have large amounts of data for traditional machine learning models to be successful. We are still okay with having fairly limited number of observations, but we should be having good engineered features for it. And the third most important distinction between traditional machine learning and deep learning models is a model complexity. As you can clearly understand, there are more and more number of layers within your neural network. So you can have n number of hidden layers within your neural network that you are defining. So there can be multiple dense layers within your network. And as the number of dense layers increases, let's say that this is dense layer 1, dense layer 2, dense layer 3, dense layer j. As the number of dense layers increases, the model complexity also increases. As the model complexity grows, we clearly know that the number of learnable parameters also increases. So there will be millions and billions of model parameters, especially in large language models. Even in any normal deep learning model, you'll be having large number of model parameters when compared to traditional machine learning models. The traditional machine learning models will be having handful of the model learnable parameters. So it's easier to tune that way. And it's very difficult for us to actually maintain and tune those many number of learnable parameters in your optimization process within your deep learning models. Okay. So these are the three primary distinctions that we have clearly understood between machine learning and deep learning models. The very first thing was feature extraction. So there was auto feature extraction in deep learning models, and it was a manual process within traditional machine learning model. And the model performance. The model performance in machine learning model tends to plateau after a particular point in time, whereas the model performance of deep learning models almost linearly increases with the increase in data volume. And there are more number of model parameters. There are more and more, like millions and billions of model parameters in some deep learning models, not in all of them. There are more model parameters for us to tune in case of deep learning models, whereas the traditional machine learning models have fairly limited number of model parameters for us to tune. Okay. I believe this particular video gave you a clear understanding on what machine learning models are and what deep learning models are and how are they different from each other. Okay. If you like this particular video, and please try to subscribe this particular channel for more such updates. Thank you.